CI question based on a pipeline processor. We are having a 5-stage pipeline which is having the stage delays of 150, 120, 150, 160 and 140 nanoseconds respectively for the 5 stages. And it is having registers that are used between the stages, and each of them has a delay of 5 nanoseconds. So this will involve our buffer delay. And we have to execute 100 independent instructions on this pipeline processor such that there are no stalls involved. So in this scenario, what will be the total estimated execution time for these processes that has to be evaluated? So first of all, let us note down what all values we have been given. It is a 5-stage processor, so we denote that by K equal to 5. The number of processes to be executed is 100, so we write N equal to 100. And now the total delay has to be calculated for the stages. We are having 5 stages. Each of them is having different execution time given. So if we look at the one which is maximum among all these 5, then it would also involve the other ones. For example, since this is a pipeline processor, so if I'm executing 2 processes in this, one is having a delay of 20 nanoseconds, other is having 10 nanoseconds, and both are executing parallelly. So by the time this bigger process would have finished its execution, the smaller one would also have been completed. So we look for the one which is having the maximum delay among these 5 stages. Which one is that? 160. This is the stage 4, and that is the most time consuming stage. So by the time the process is out of this stage, the others would have also been incurred for. Hence, the total delay would be given by 160, which is the maximum of all these 5 stages. That will be responsible for the delay. And to this, we will need to add if there is any buffer delay involved. We have already been given that there are registers which will incur buffer delay, and its value is 5 nanoseconds. So our total delay becomes the maximum for all these stages plus the buffer delay, which is 165 nanoseconds. So now we have got all the values, and we can simply calculate the execution time in a pipeline processor, which is given as K, which is the number of stages, plus N minus 1. N is the total number of processes to be executed, and that multiplied with the total delay. And how do we get this expression? In a pipeline processor, the time taken by the largest one, this is the largest process, and at this point of time, this process is completed. So now in every second, we will have one more process completing its execution. So that is how we get this formula. You can check out the derivation, it's quite simple. And we can substitute the values in it to get 5 plus N is 100, so N minus 1, 99. That multiplied with the total delay, which is 165. So we get 104 times of 165, which is 17160. So it is approximately 17,000 nanoseconds. That is the unit they require. And this is the total execution time for all the given 100 processes in this pipeline processor. So that is our answer, 17160.